Hello, PVHS students. Okay, so today we're going to see where the trigonometric function, the sine wave and the cosine wave, where do they come from? So we're going to create an application that models the sine wave and the cosine wave. So we're here. So please sign in to GeoGebra at geogebra.org. And we're going to go new GeoGebra Math Apps. And we're going to choose Graphing Calculator. Okay, so we don't need the calculator below. Excuse me. So make sure we're in the Move menu, and let's go and turn on the orthogonal grid. We want to see the graph paper. Okay, and we're gonna move the screen a little so it's centered, a little more to the left, and we're going to create a sine tracer. So the first thing we want to do is create point 0, 0. This will be the center of our circle. So we're going to use the circle command, open parentheses with center A and radius 1, because we're talking about the unit circle in trigonometry. We want to make our mathematics as simple as possible, so the radius of our circle is held to 1. Okay, so now we need a point that rotates around this. In order to do that, we need a slider. And we're going to place a slider anywhere in the white space. Now remember, when we did the measurement of rotation, we had a slider and we used the angle. So we were measuring rotation in terms of degrees. However, the application you won't be able to see the sine wave traced out if we used angle, because our x-axis would be too long. Because just imagine 360 degrees is one rotation. However, if we use radians, that's 6.28 radians is one rotation. So now we've kind of shrunk or dilated or compressed our x-axis if we use radians or numbers instead of degrees. So we're going to go from negative pi divided by 2, or negative 90 degrees, to let's say 4 pi, which is 2 revolutions. And our increment, for now, let's put it at 0.1, or a tenth of a radian. Yeah. And so then press OK. And now we have our slider. And okay, so now let's move a little quick. We can move a little quicker. Let's choose point B to equal the rotating object, which would be cosine of A, the slider value, comma, sine of A. And then press enter. And now we have B. And if we click make sure we're on the leftmost move menu. And if we click the slider play radio button, then we should see the slider going around twice. And then we're going to negatively rotate. Okay, so we don't really want to do that. So let's go ahead and double tap on your mouse key, go to Object Properties, and we're going to change this from, let's go to Object Properties for the slider, and we're going to go change from oscillating to increasing, and then we can close out. Okay, so now we'll just be increasing. So we're going counterclockwise, positive rotation. Okay. Okay. So now let's stop it somewhere, because not there. How about there? Let's go around. Let's stop it in the first quadrant. Okay. Let's stop it somewhere in the first quadrant here. Okay. Now we're going to create a perpendicular line. We want to see that reference triangle. So let's go and create a perpendicular line. We're going to select point B, and we're going to select the x-axis. We want a perpendicular line that goes through point B and is perpendicular to the x-axis. Now let's go to our point menu. There's an intersection there that we're interested in. So let's create the intersection here. And now we can create our polygon or our reference triangle. Okay, so instead of creating a reference triangle with the polygon tool, though, let's just use line segments. And I'll show you why in a few seconds. So now we're going to click on B again, go down to C, click on C again, and go down to A. Now I want to remember the sine function is, well, let's turn off the perpendicular line. So if we go here, see the perpendicular line selected, unselect the view. Okay, so now we're in the leftmost menu. Let's select the vertical part of the reference triangle, and let's change that color to red. And let's increase the thickness of the line to, let's say, 5. Let's do the same thing for the cosine, but since it's different, it's horizontal, let's change that color to blue and change the line thickness to 5. Okay, so now the sine is represented by this. So the sine of this angle here would be approximately 0.7, let's say. If I went across, this is about 0.7. Okay, so and then this angle, I'm not sure what this angle is. We could measure it. It's about 45 degrees. So if you wanted to check in your calculator, you can say sine of 45 degrees is about 0.7. Okay, or maybe like 0.6, 0.65. The cosine of this same angle, which is about 45 degrees, or let's say 40 degrees, is about 0.75. Okay, so now let's trace out the curve. So now what happens if we flatten this rotation out and we graph it along the x-axis? Well, let's ABC. Let's go. Let's use point D equals open parentheses A, comma, sine of A, and then hit enter. Okay, so our point D is the x value of point D is the x-axis, the radian axis, and then the y value or the height is the sine. So it's this distance here. Okay, so now let's press play and see what happens. Okay, we see this D is moving in a weird fashion. It's going up and down, kind of like a wave. Right? If we zoom in a little, we can see more of it. And here we go this way. So now we can't really see what graph it is. So let's pause it. Let's pause it, and now let's double tap on the point itself and say trace on. We're also going to change this color to red because it's associated with the sine. It's the sine wave. We're also going to connect a line segment from the height of B, which is the height of the vertical segment, and D. And we're also going to color code this. Make sure we're in the move menu, and we're going to color code this also red. Okay. Now go ahead and press play and see what happens. We've traced out the sine function. Okay, we could do the same thing for the cosine function, but I don't have much time on this video left. Okay, so for now, we'll stop here.